So today's section is on solving quadratics, solving quadratic equations. And so we're going to begin, though, with a little bit more on review on circles, because this was part of 3.2, but there's so much to cover in there. I just held off on the circles. So this is actually part of 3.2. I just wanted to get, we just didn't have enough time to do that on the last one. It was so long already. So we're going to come back to the 3.3, but so working with circles. So here is the equation for a circle. And again, you need to get that written down. Okay, get that written down so you understand, have it. And so if I want to find the center, and it's in this form, it's pretty simple. It's just HK. And then this is R squared. So if I wanted to find what R is, I could just square root this. So if it's 9, I'd just square root it, and the radius would be 3. So you're going to be asked to find the equation of the circle, given the center is 4, -3, and the radius is 5. So all I do is I substitute in H and K, and then square my radius. So that's going to be X, it's a positive 4, right? So it's going to be -4 squared plus Y, this becomes a +3 squared equals 5 squared, which is 25. And that's all it is. But you got to remember these signs because the original is minus. So if I put a 4 in for H, it's X minus 4. If I put a -3 in for either one, it's a minus a -3, so it becomes plus. So again, it's always using the opposite. It looks like you're using the opposite of those signs. Okay, what about if we have a center at 0, 0, and I want to put in a 0 here and a 0 here? Well, that's then just going to be an X squared plus Y squared equals 3 squared, which is 9. So this would be a regular. So let's go ahead and graph these. I'm going to start with this. So let's graph this one first. I think I can pretty much get it in there. Okay. All right. So here we have a point at 0, 0, and it has a radius of 3. So if I want to graph that, I just do 3 points. You know, it goes every direction, 3 points. And it may not look like a perfect circle. Mine usually end up looking like an oval. But however you can draw that circle, okay, that would be the graph of that. Now this one has a little bit of a shift in it. Again, I might run out of room here. Let's see if we can, yeah, I'm gonna run out of room on this. I'm sorry, I didn't do a very good job planning that. So the center is 4, -3. So we're gonna go over 4, 1, 2, 3, 4, down 3. Okay, and then our radius is 5. So we're just gonna count 5 around on each point. So 1, 2, 3, 4, 5. 1, 2, 3, 4, oops, 1, 2, 3, 4, 5, and then down. so didn't plan real great on that, did I? So here is, and it looks horrible, but here is our circle with a center point right here. So it's pretty simple and pretty ugly, but there you go. All right, now I've kind of ruined the whole part of my next part, but I think we can still work with it. All right, so this says use completing the square to find the center and radius. So now I want to come back here and I want to get it into this form right here so I can find what the center and the radius is. So this is kind of using completing the square. So here's what you need to do to begin with. You need to get your x's beside each other, your y's beside each other, and your constant, get rid of your constant. So here we're going to have an x squared plus 2x, got the x's together. Okay. And then we have the y's. So I'm going to leave a little bit of space. Okay, so a little bit of space. So then we have the y squared plus 6y. Leave a little bit of space. And I'm going to add 15 here, which means I have to add 15 here. So we're there. All right, so what we've done is we've got rid of the constant, added that. And now we're going to do half the middle term and square it. So what's half this middle term is 1. And I'm going to square it. So over here I took 1/2 of 2 is 1, and then we're going to square it and get 1. So we're going to add 1 here. Okay, but if I do that here, don't forget you got to add 1 over here. All right, now here we're going to take half the middle term. So we're going to take half of 6 is 3, and we'll square it, and we'll get 9. So half the middle term squared is 9. Don't forget to add it to the right side. It's easy to forget because you got to balance it. You can't just add a value to one side of an equation. Now let's bring this down. There's a plus sign in here. Now let's bring this down and factor it. So x, bring down the sign, and whatever half the middle term was. Okay, plus, we're always going to have a plus there. We're going to bring down the y, half the middle term, and then equals 16 plus 9, 25. So that's not too bad. And once you get it here, then what's your center? So your center is -1, -3. Don't forget, you got to change those signs. And your radius is the square root of 25, which is 5. All right, I'm going to bring this problem down here. So if you want to try this one on your own and then come back, see how you do, that's great. Let me get a little. All right, so let's get our x's together. There's another example. So we'll get our x's together, minus 4x, leave some space, and then we have y squared plus 6y, leave some space, and then we'll subtract 9 from there. Okay, so half our middle term, it doesn't matter positive or negative because we always square it. So just half of 4 is 2. 2 squared is 4. And don't forget to put it over here. Okay, half the middle term is 3. We square it. 3 squared is 9. And then we have to put it over here. All right, let's take it down and put a plus there then. Take it down to factored form. So the variable, the sign, half the term. Don't forget that sign now is negative. Plus the variable, the sign, and half the term. All right, and so now you can determine what's the center. The center is 2, -3, and the radius is the square root of 4, which is 2. All right, cool. All right, so now let's talk about solving quadratic equations. So there's multiple ways to solve quadratic equations. And so one of those is the zero product property. So you might be asked on an exam, solve this using the zero product property. So what that really is factoring. Okay, so I'm going to start actually with this one. So because this a is 1, I can just break this into 2 sets of parentheses, split the variable. Okay, what multiplied equals 9, positive 9, factors of 9, that I could get a -6. So if I come over here for 9, well, my options are 1 and 9 or 3 and 3. What's going to give me 6? Well, 3 and 3. And I need to add them to be a -6, so it's going to be a negative, multiplied, positive 9. All right, now set each of those equal to 0. Got to take it one more step. So x equals 3, and this also is x equals 3. So that's kind of a double root. It's a multiplicity is what that is, and it just means you have the same root. So I really only have to write it one time. I don't have to write it twice. That means that parabola is going to touch the graph at x equals 3, and it's going to bounce right back up. So it won't go through the x-axis more than just one point, only at x equals 3. So it just touches it and comes back up. So I don't have 2 solutions because it's a double root, multiplicity of 2. Okay. All right. So now this one, what I would normally do is I would say, okay, let's divide everything by 2 since I can, evenly. And then I'd be at a pretty simple equation like this. But I'm just going to review using the AC method. Even though I wouldn't have to on this one, I'm going to use the AC method. So the reason why it's an AC method is because you take A times C. All right. So A times C is 32. The negative we can keep on there. We can talk about that a little bit later. So what multiplies to equal 32? Can I get 4? So go through all the factors of 32, but I know that 8 and 4 give me 32. And I could get a positive 4 by taking a positive 8 and a negative 4. And if I multiply those together, we get a negative 32. So when you use the AC method, you only use it when this number is greater than 1. All right, that's when you use the AC method. And so we're going to bring down the first term. And what we're going to do is we're going to replace this with these. So I got to put whatever this variable is, I got to put them on these. And I can write them in either order. So we're going to have a plus 8x and a minus 4x. And then we bring down the last term. So really what I've done is I've just replaced this with this. Okay, or replace this with this. I've probably said that backwards. All right, now that we have 4 terms, that's when we know that we use the grouping method. So the grouping method, it means we're going to split it exactly in half in front of the sign. I'm going to factor out a greatest common factor over here. So they have a 2 in common and they have an x in common. So let's factor that out. So when I factor it, what I'm really doing is dividing. So 2x squared divided by 2x leaves me with an x. And 8x divided by 2x is a positive 4. Okay, now whatever this sign is, I bring down. Okay, whatever that sign is. Now what do these have in common? They have a 4. So we're going to factor out a greatest common factor of 4. And so what I'm really taking out of there is a negative 4. So if I divide this by negative 4, you have a positive x. Negative 16 divided by negative 4 is a positive 4. And that's our goal, is for these to be the same. So now what can I factor out of here that I can factor out of here? Well, now I can factor out that x plus 4. So if I take an x plus 4 out of here, I'm left with a 2x. If I take an x plus 4 out of this, I have a negative 4. All right, so x plus 4 equals 0 and 2x minus 4 equals 0. X equals a negative 4. 2x equals 4, x equals 2. So you can check these. If I graph this, then this should go through the x-axis at 2 and negative 4. If I graph this, it should just touch the x-axis in one point, and because this opens up, it's going to touch that axis at 3. Okay, so 1, 2, 3, it's going to touch that axis at 3 and then come right back up. It's kind of what that graph will look like. But check them, because sometimes we have what's called an extraneous solution, and that's one of these that really actually is not a solution. And so it's not a real solution until we check it. So always just check that, get comfortable with doing that, okay? All right, so square root property, this isn't a way to really solve I guess that is solving a quadratic equation, but I think it's really just figuring out how to solve for x with that. So here, remember, all we do is square root both sides, because that undoes this, 1/2 times 2. And so put a plus or minus on here. So x is equal to a plus or minus square root of 4, which is 2. All right, same thing over here. Now, the difference here is 8. That's not a perfect square. So I'm going to have x equals the square root of, do I know a perfect square? Maybe 4 times 2, right? And there's a plus or minus on there. So I could bring, the square root of 4 is 2. So I can bring a 2 out of here. So what I'm going to have is x is equal to a plus or minus. I'm going to bring a 2 out. And then I still have a 2 left under the radical. So I would just leave it like that. Don't take it to a decimal. We want exact answers. All right, now we've got this negative. Remember the negatives here? So we're going to use complex numbers. So here, x is equal to a plus or minus. And what is the square root of negative 4? Well, I know the square root of 4 is 2. And how do I bring this negative out? With an I. So if I were to graph this, this would not go through the x-axis. It might be a parabola just in one of the quadrants, opening up or down, but it won't cross the x-axis. All right. This will cross it at 2 and 2, 2 and negative 2. And this will cross it, whatever that is, as a decimal, that's where that's going to cross it at. All right, so completing the square. So we're pretty good with completing the square, right? Because we just did it. So let's just do a couple of these real quick here. So let's begin. This is a 1, so we don't have to do anything with that. We'll go ahead and get rid of this negative 2. We'll just leave some space there. Equals a negative 2. All right, half the term and square it. So 1/2 times a negative 4 is a negative 2. And if we square a negative 2, we get a positive 4. So half the term, remember it's always going to end up being positive here. So whatever half that is, which is 2, we square it and we get 4. But don't forget, we got to put 4 on the other side. That's super important because that's where you're going to get off. A lot of students forget that. You got to keep it balanced. That's why the purpose of an equation. That's what this equal sign means. Balanced here, balanced here. All right, so let's factor. So we're going to bring down the variable, the sign, half the term, 2. All right, let's square root both sides. So this becomes x minus 2 equals a plus or minus radical 2. So we're going to add 2 to both sides. So x is equal to 2. Put that 2 in the front, okay? Plus or minus radical 2. Don't put this at the end. You could, but it just is better to write with your radical at the end. Okay? It's not wrong if you don't, but. All right, so those are our 2 solutions. Don't make them a decimal, just leave them in exact form right there. All right, let's take a look at this one. Now this one is kind of nice because it's already got this we've already got this, this is gone. We don't have that. So we can just leave it like this. But what's not fun is this is going to deal with a fraction, and that's why I'm having you do this one because it's a little more challenging. So we need to divide everything by 8. So x squared, and I'm going to reduce 2/8 down to 1/4. Leave a little bit of space and 3/8. All right, so we're going to have to take half this term, but you can do that. You can do half that term. So 1/4 times 1/2. So what's a half of a fourth? Just multiply straight across is 1/8. That's 1/2 of a fourth. Now, and then I have to square it. So what is 1/8 times 1/8? 1/64. Whoop. 1/8 times 1/8 is 1/64. So that's what we're going to fit right here, 1/64. And then I have to also do 1/64 there. All right, so that's not so bad. You can do that, multiply straight across. That's all you got to do. All right, so now bring down the variable, excuse me, bring down the sign. Okay, and what was 1/2? What was 1/2 of 1/4? It was 1/8. Okay, now over here, we have to get a common denominator. So what is something both 8 and 64 go into? Well, they both go into 64. So I'm going to come over here and just show you that over here. So 3/8 plus 1/64. So let's put this into 64ths. So what do I have to multiply this by to get 64? I got to multiply it times 8. So whatever I do to the denominator, I have to multiply the numerator also by 8. So there we have 24. Plus 1. Now we have a common denominator, so we just add the top, 25/64, by just adding the top. So you just have to get a common denominator. All right, so it looks like it's going to be a lot more difficult than it is, but it's not so bad if you just do it small steps by small steps, okay? All right, now we're going to square root both sides. This is a plus or minus. So we have x plus 1/8 is going to equal plus or minus. Well, what's nice here, these are both perfect squares. So that's 5/8. So solving for x, we'll subtract 1/8. So minus 1/8 plus or minus 5/8. So if this confuses you, write it out. So x is equal to negative 1/8 plus 5/8. And x is equal to a negative 1/8 minus 5/8. So the common denominator, which is nice, so it's negative 1 plus 5. So x is equal to 4/8, which reduces down to 1/2. And then this is a negative 1 minus 5, so x equals a negative 6/8. Let's see, we can divide both of those by 2, so a negative 3/4. And if you want to go back and check this, put your original problem up here into the calculator, and it will show a decimal, but that's negative 0.75, and this is 0.5, so you can still figure that out on there to see if you did it correctly. All right, so that's probably one of the more challenging ones that has a fraction, but really I don't think it's too bad if you just kind of go in, slow steps. Just kind of go slowly. All right, so that's completing the square. So the last couple of things we're going to talk about is using the quadratic formula. All right, so a quadratic formula is x equals, and you have to memorize this, you guys. Okay, so work on it. Negative b plus or minus b squared minus 4ac, okay, all over 2a. Now, there it is, all over 2a. Now, this is something, eventually you'll be able to solve quadratics however you want to. You can factor it, you can complete the square, or you can use quadratic formula. Entirely up to you, whatever you're most comfortable with, all right? But for the first exam on chapter 3, you're gonna have to be able to do all the methods. So you gotta be sure that you can show me this. You gotta show me the work on this because it's gotta be done by hand. You can't program it into your calculator and put it in and give me an answer. Okay, you gotta show me. I know there's like a song that goes with this, and I'm not going to do that for you, but I want you to know that the quadratic formula actually is derived by completing the square. And I would love to show that to you, but we don't have time. It's something I try and do my face-to-face if we have time, but it's kind of cool that this actually comes about from completing the square. You start with a standard formula and you complete the square, and this is what you end up with. So that's where it's derived from, all right? So I wish we had time to kind of show that proof, but we don't, which I'm sure you're probably sharing. All right, so first thing that's important is that you have everything on the same side of the equal sign. All right, otherwise your signs are going to be off. So get everything on the same side of the equal sign. And then all we do is just fill it in. So x equals a negative b. Okay, b squared, so 6 squared minus 4. A is 2, c is a negative 3. All over 2 times a. So we just fill everything in. And I'll show you exactly where I see most of the errors. So x equals a negative 6. Okay, so you need to show some steps, right? You got to show steps in this. So 6 squared is 36. Now, this is where I see the error. This is a negative times a negative, so that becomes a positive. All right, so what is 4 times 2 is 8 times 3 is 24. That sign, those signs mess students up. I don't know, just got to pay attention, I think. You can't just copy one that said this one's plus, so you think that's always going to be plus. Pay attention to the signs. All right, and then on the bottom is 4. So again, we're at x equals a negative 6 plus or minus, what's 36 plus 24? 60. All right, so do we have a perfect square in 60? Let's see, so 60, 4 times 15 is 60. Yeah, we sure do. All right, so this is the same thing as 4 times 15. So I have this perfect square, so I can bring that out. Okay, so I'm going to be left with a negative 6 plus or minus. I'm going to bring this 2 out, so I have a 2 and I have a 15 left underneath, all over 4. Now, do these have something in common that I could factor out? They do. They have a 2. But what I do not, please do not do this, because I will mark you off. Don't just take a 2 out of here, a 2 out of here, and a 2 out of here. All right? You need to factor it out. So what do they have in common? First of all, I don't want this to be negative either. All right? So, but let's focus first of all. Let's focus on, if we don't want this to be negative, we'll take a negative out. We'll factor out a negative. And then what number do these all have in common? They all have a 2 in common. So let's factor that out. Negative 6 divided by negative 2 is 3. 2 divided by negative 2, so this is, oh, okay, we got a plus or minus here. So I'm going to do this. I'm not going to have you take out the negative right now because I don't want you to get too confused. So we'll just take out a 2. Okay, then we'll have a negative 3 plus or minus, divide that 2 out, so it's a 1. 15 all over 4. So all I did, I decided not to mess with the sign right now because this is going to mess you up here and I don't want to do that. So we'll just leave the negative right now. So just take a 2 out of here. That's what I did, factored a 2. And there's a 1 here, but I don't have to show it. But there's a 1 there. All right, so then this cancels into here 2 times. So I'm going to write the answer over here since I'm running out of room. So x equals negative 3 plus or minus square root of 15 all over 2. That's the simplified version. This is not simplified. This is simplified, so I want you to get it to here. And then you can leave it like that. This is an exact answer. I don't want it in a decimal where it becomes an approximation, so you leave it just like that. All right, let's do another one real quick here. So here we have, now this one, remember we need to have everything on the same side of the equal sign so that our signs are right. So minus x, so I'm going to add 4 to both sides. and run out of room there, equals 0. All right, so I have 2x squared minus x plus 4. All we did was add 4 to both sides here, equal to 0. So here's your a, here's your b, and here's your c. So we'll do x equals a negative b, so a negative 1, right? B is negative 1. Plus or minus b squared, so a negative 1 squared, minus 4 times a, which is 2, and c, which is 4, all over 2a, which is 2 times 2. All right, so let's work this out. So x equals a positive 1 plus or minus negative 1 squared is 1. Okay, now notice this is just a negative times a positive, so it's going to be a negative. 16, 8 times 4, so it's going to be 32 all over 4. All right, so x equals 1 plus or minus negative 31 over 4. Okay, I'm just double checking everything's at negative b squared. All right, so, which is totally fine. It just means that this is going to be an imaginary number, so when I graph it, my parabola doesn't go through the x-axis. There's no real solution. That's all that means. So how do I write this? X equals 1 plus or minus. We're going to bring this negative out, so that's going to become an I. Put it in the front of the radical, square root of 31. That doesn't have a perfect square in it, all over 4. And I put this here because if I put it at the end, sometimes it's hard to determine if you accidentally get it kind of under the radical. So always put the I in front of the radical. All right, so you can practice a few more out of your book if you want to do that. All right, last thing is talking about these discriminants. So the purpose of a discriminant is so I can determine what my roots are going to look like on a graph before I graph them. What are my roots going to be? How many roots am I going to have? How many solutions? Now remember, when I talk about roots or zeros, solutions, it's where it goes through the x-axis. And so that's what the discriminant, that's the only thing the discriminant does right now that we're going to work with is determine how many solutions you're going to have. So on an exam, I'll just say, given this equation, use the discriminant to determine how many solutions there are. And so what you're going to have to do is what you're going to have, we're going to put it in. So notice this is what's under the quadratic formula here. This is the discriminant right there without the radical. So I don't know if that helps you remember it or not, but so we're going to just do b squared minus 4ac. So let's do b squared minus 4ac and see what we get. So here, negative 4, remember this is a, b, c. All right, so negative 4 squared minus 4 times a times c. So what do we get here? So 16 minus 8, which is 8. So if this number is positive, then that means you're going to have 2 real solutions. So I would write 2 real solutions. Or 2 real zeros if you want to say zeros, it's the same thing. So what that means, and you can look at this, you graph this, it means it's going to go through the x-axis in 2 different places. And I don't know what they are, but I just know that I can tell you that it's going to have 2 real solutions. All right. And so let's look at this one. So this one, b squared minus 4ac. So we have 8 squared minus 4 times a, which is 1, times c. So what happens here? 64 minus 64. 14 times 16 times 1. Well, that comes out to be 0. So if your discriminant is 0, that means you have 1 real solution. And that means it's going to touch the x-axis and either go back up or back down. So this is positive, so it's going to go up. And I'll show you a picture of those, I guess, so you see. So what your answer would be is 1 real solution. You would show me this work, and then 1 real solution. So then, now notice these are not all on one side of the equal sign, so it's going to be off if you don't. So I want to subtract 4x, I'm going to add 5 and set it equal to 0. You want everything on one side of the equal sign. Okay, now do your discriminant. So b squared minus 4 times a times c. So this is 16 minus 60. So this becomes a minus 44. So what happens if it's negative? That means that you have 2 non-real solutions. So this is 2 non-real solutions. And what that means is when I graph it, it won't go through the x-axis. But that's what you're telling me. You're just telling me that, okay? And you know what you can't do is you can't put that in and go, oh, it has one real solution because I see it on the graph. You got to show me using the discriminant. This is something that has to be done analytically by hand. All right, I don't care if you check it, but you have to show me how you do that by hand. So let's look at, let's just take a look at what those graphs are. I'm not sure I still have those up anymore. Okay, I can do that real quick here. Let me get Desmos up real quick again. And I just think it'd be good to get a picture of it. Okay, so. All right, so here is our picture. So here was our first one that said use the discriminant. So we had 2x squared plus 1. And so what we found is it had 2 real solutions. Now we don't know what they are. I mean, I could find them now, but we don't know what those are. But what you are telling me is it has 2 real solutions. So I know it's going to go through the x-axis in 2 places. Okay, so let's look at the next one here. Okay, so there's the next one. Well, look, it only has one point where it crosses or touches the x-axis. So that means there's only one real solution. It doesn't go through in 2 places. And then lastly, okay, there's our last one. Well, it doesn't even go through the x-axis, so it doesn't have any real solutions. Any real zeros. Again, solutions, zeros, roots, they kind of are similar in meaning. I use them interchangeably, but it doesn't have any real solutions if it doesn't go through the x-axis. So these are going to be complex in here. All right, so that is our solving quadratic equations, all right, on section 3.3. All right, have a good one.